It works. The game is played with one move left. There we go. Game 1. How about that? My name's James Taylor and welcome to another episode of Invalid Entry. How about that for timing of that swivel round? I'm quite a big gamer. I've been a gamer all my life, and I'm quite old, so I remember playing really old-fashioned games. I've got a massive fan of puzzle games. I'm also a computer programmer, an engineer. I don't get to write code at work, which is why I started doing these fun activities in the evening to sort of play around with code at a much different quality level than I've normally done my day job. Just throw things together, hack things together, and just have a bit of fun with computers again. So I am a massive fan of puzzles. I'm a massive fan of programming, and I thought, how about I merge the two together and make my computer program play games? Not write a game, that will be other episodes, but this is how to make it play a game. So let's move over now and have a quick look at the game in question. And I'm just going to, before I open up that tab, just make sure my tabs are open in the right place. So, over the right URL. So the game I'm going to play today is a game called Drench. It's a really simple little game. Now, often with these little puzzle games, you have to sort of play around and work out what is and isn't a good strategy to play. So the first couple of times I played this game, and it's available by the Flashbang URL. There seems to be a bit of a weird zoom going on my screen. Let me just see if I can correct that. There we go. Flashbang going on the URL. And the idea here is you start in this top left-hand corner here, and basically you select a colour, and it will fill the square. So if I select pink, this will become pink, and then it will be joined to these other pink. Then I might select another colour here, I might select red, and it joins to all the red. And then any attach that, so I might go light blue, and then green, and so on. And the idea is to colour the entire thing one colour before you run out of moves. And if you succeed, the round resets. Instead of having 30 moves to go in, I then have 29, and so on. And you really keep on playing until you can't finish a round. Because it's a random grid, there are some limitations as to what the maximum score would be. I get down to usually about 24, 23, I think is the most I've ever done. I've been playing it a little while. And at that point, I have actually done it in less than 20 moves. It's just really luck. And when you get down to 23, I've just never had the luck of a really nice board where there's been lots of things joined together. Anyway, my strategy when I'm playing this is I'm really looking for the big things that will join up and give me access to a lot more squares. So at this point I think I go for red, because then if I go for red I can probably go for like the light pink afterwards. So I can go red, light pink, and then I'm looking at the next 2 or 3 moves at a time. How hard would that be to turn into a little script to interact with? I don't know. When I've seen other people make these videos of how to make your computer play games, and they've often gone down the AI route, and I'm not doing AI this time, they often recreate the game first. They have the game in a very controlled environment. I'm not. I'm actually going to make my computer play that exact game from this exact URL at the top. Completely unaffiliated. No idea who owns this. They're making money for advertising, so, you know. So the first thing we're going to do is to actually control this. We're actually going to use something called Selenium. Now, Selenium is actually a tool we use at work all the time to do testing, unit testing. Not unit testing, sorry, acceptance testing, where we basically are running the service, and then we'll use Selenium to actually load the web pages, take snapshots of the web pages, check they actually look right, style, CSS, JavaScript, interact with it actually in a browser, rather than just calling APIs and things like that. So we use Selenium an awful lot, and Selenium is basically wrapping around the browser. And when I run Selenium, you will see it pop up saying this browser is under control of automation. It is a test tool, but it works beautifully for these kinds of things. You install Selenium. I'm on a Mac, so I just do brew install Selenium, or Selenium-driver, or Chrome driver, because I'm going to run it in Chrome. And then you pip install Selenium in your Python, because I'm going to write in Python. If you're on Windows, I think there's an installer for it. Just Google how to install that. That's the easiest part of the situation. So we're going to basically write this program from scratch, and over here, I'm in my Virtualenv. I've got a brand new thing. So from Selenium import WebDriver. Now this is going to be the main way I interact with this thing. Let's just go. So browser equal WebDriver.chrome. Now I will point out every time you call this, it will spawn a new Chrome window, and they'll stack up down below. Not a new Chrome thing. It's the entire new Chrome process controlled by it. Browser.get http flashbynight.com drench. Okay, so let's just run that. Now, it takes a few seconds to run, and of course I'm running this in a Jupyter notebook, so I can just sort of mess around with the code. And there it goes, it's loaded. You notice here it says it's been controlled by the automated test software. That's fine. If I can still interact with it, but I actually have a reference to it here, so I can do things to that. So one of the things I can do, browser.save screenshot, screenshot.png. I can then, I can save that. I can actually, and it actually does, it takes an element of that. I can do things like pull up elements, inspect elements, test the values of elements, all that kind of stuff. Now, this is very, very super powerful because we're actually going to be looking at this image here to sort of work out what the grid is like and work out what the optimal button to press is. If we look very quickly at the source, we notice that it's all done in a canvas. I don't really want to mess around with the canvas. I don't really want to interact with the page at all. But we notice here there are 6 buttons which relate to the 6 buttons here. There's also a reset button as well if we really want to do reset. There's also handily a class here with moveNum, which is this number up here. So we can write a couple of functions really quickly just to really help us get some usability out of this. So the first one I'm going to write is def get moves browser. Now I'm going to pass my browser in every time, just so I have this context of the browser, and it's going to be element equals browser dot find element. Now usually I like to find elements by ID, but in this case I didn't write the page, so I'm going to find it by class. Okay, and the class name I think was moveNum, like that, and that gives me that web element. Now to get that back, the web element has attributes, properties, all the child elements, anything like that. Now in this case, because I've already picked the final element, I can just do .text. However, I'm going to want it as an integer, so I'm going to assume, I'm not going to put a semicolon in, I'm going to assume it's always going to parse. If it doesn't go through me a parse exception, I can catch that exception elsewhere. So return the int of value, the parsed int value of that number. Okay, so run that, and I can just do get moves browser, and that should come back with file element by class name. There you go, 27. If I click a few more buttons and run that again, 23. So that interaction's already there. Already I've converted this bit of text here to a number. My program already has some use. Again, very powerful for testing. You want to say, I want to log on as a particular user, check that their actual display name, I logged on as the right user, check these elements. You script this out. You often use something like BDD, business event. We have stories saying when you log on to this, check that your user profile has these values or whatever. The next thing I want to do actually is I want to actually program up a click button function, because I want to, instead of having to code it every time, I'm going to have a generic one. Because those IDs where B1, B2, B3, B4, I suspect the JavaScript, when you click it, it's calling the same bit of JavaScript and picking it up. So def click button browser color. I'm going to use B1, B2, B3 as my colors. I don't actually care what the colors are. And that beer has a cap on. Don't drink that beer. Drink this one without the cap. Pro tip. And that just spilled everywhere. Second pro tip, drink beer, don't spill it everywhere. It's really, really frothy, so I don't know what's going on. So basically, but what we're going to do is we're going to implement this click button. I'm going to use B1, B2, B3 as my elements involved with that. And basically what that's going to look like is, again, the first thing I want to get find the element I want to click and then click it. So I could do the same thing. I could do web element equals browser dot find element by ID, and then pass in the ID. Now here I'm going to pass in the color, and I could do web element dot click, but I'm just going to do dot click here and get rid of that because I don't actually need to have the reference. Like that will suffice. So that little wrapper there is going to be nice, and now I should be able to do click button browser B1 like that, because I didn't run that bit of code. There we go. You can see it clicking, and I can run it by B2. And you can see there in the background, I'm pointing my finger, and obviously you can see what I'm pointing at. You can see it changes the pink over there. So I'd run it again, B3, changes colour. Really nice. And also I should be able to do reset here, and there's no such element. Excellent, because if I actually look at inspect this code, it actually tells me that this is the center block, button box, reset button, reset button. Apparently it's reset button. There you go. Resets the game. Nice start. So we now have a nice little function, couple of functions there, super powerful, will come to help us. I want to quickly point out this changes in size. As you resize this game actually resizes that. And also, depending on what screen on the colours change, the browser thinks the colours change because of how the colour profiles work on the screens. It's going to become relevant later on, just trust me. So we now actually are able to build a really stupid game-playing robot at this point. I can basically make choices equals an array of B1, B2, and so on, right? If I do it fully, B3, B4, B5, and B6. I'm just going to import random here. And then I can just do choice equal random.choice choose choices, and that would choose one out of those elements, and then I can do print choice. I think again, write code, don't hit run. There we go. Because it's called choice. I obviously know what I'm doing here. So B1, B2, this goes B3. I'll be hilarious. B4, there we go, nice. So what we can now do is I can do click button browser choice. Okay, and in fact we can even do reset button for while get moves browser is greater than 0. I'm also going to import time. Here, bearing in mind some of these are blocking, so like getting the values back is actually a blocking move, I do want to let the computer catch up a little bit, so time.sleep 0.5, just to let sleep for half a second on each loop, and we can now run this, and you can see it's picking random colours. Not very clever, probably isn't going to win. We'll find out in about, well, 7.5 seconds. Worst AI of a computer opponent ever. Game finished. Also because that hit 0. Exited nicely. No errors, no exceptions. Bonza. Absolutely terrible AI. We can do better than that. I know we can. So what we're going to do now is actually look to see whether or not we can actually model the grid and actually make a decision. So we can't really make decisions. I guess we could say don't pick the choice you did last time. That would be an improvement. But I actually want to look at the information we have and see if we can just make a very simple robot to think about the grid as a whole. And this is where it gets a bit fun. Now, the first thing is you can take a snapshot, which I've shown you already. You can take a snapshot. What I want to do is actually find this element and just take a snapshot of that element. And it will look a bit different, and if you saw the intro then you would know what this looks like. It sort of will flash a bit weirdly, but basically I'm going to write a new function here called getGrid. Now what this will do is web element dot equals browser dot find element by ID, and the element ID of this is called canvas holder. That's what the developer of this game called it. It's not a standard thing. It makes sense because it is the canvas. It's a holder div for the element. Makes sense. Web element dot screenshot. Now, the difference between this and what I did here was this did it on the entire browser window, i.e. the root div, whereas this is doing it just on the div of that one element. And again, I'm pointing with my hand. I do apologise. I've got to point the mouse. So what this is going to do is just grab that, and we're going to call this div.png. So what we should now be able to do is I'm going to get rid of all these things here. Just cut all these out. There we go. Let's go to the bottom. Cut. So get grid browser. And you notice it flashed weirdly there. That's it just grabbing that image. Want to actually check that actually worked. So I'm going to import import pill. I'm going to from pill import image. There we go. That's probably a better. There we go. thing to do. So the next thing we're going to do here is load that image. im equals image.open. You could use your favorite Pygame library for importing images if you want to. I'm not using Pygame today. Div.png. You actually can screenshot this as a base64. I think it's like screenshot underscore base64 something like that, and then I could use image to load that, but by saving it to disk I can actually open up in Photoshop later and do some analysis of it. So let's have a quick look at that, and it's thinking about it, and if I just return that in Jupyter, it will actually show it. So that actually is the PNG. Something to notice here is there's a 1 pixel border on the top left, but not on the bottom right. So I wonder if there's a bit of a Chrome thing where it thinks the div is this side, it actually does go one over. But anyway, just bear in mind there is a 1 pixel border, a little grey outline there, which isn't an artifact or Jupyter display, it is actually on the picture. But you can see here, I now don't have to worry about the size of it. Also, what's interesting, if I resize this a little bit like this and run that again, and run the div, you'll notice I get a smaller picture here. It actually is a picture of what is on the screen at that point in time, saying no pixels, pixel, pixel, perfect. Makes it very handy for testing. So, it isn't very useful when I reset the game. It is very useful when the game is reset. So, what we want to do now is we're going to want to process. I don't want the image itself isn't very helpful. I want to actually process this image, and all I need to do is sample 1 pixel from each of these cells. Now there's 14 cells across and 14 down, but as I said, the size changes. So the first thing we're going to do is we're going to write a new function. I'm going to move this one to the bottom. This one's going to be handy later. I will say that now. It's going to call this one process grid. So basically, this is going to do that im equals image.open div.png. So it's only going to work really after you've done the God, I've grabbed it back for the thing. By the way, the way I'm actually working here is in the bottom of my head. I'm doing something called comment-based programming, but I've already done it in my head. Basically, I'm going to do while game is playing, get the grid, process grid, make decision, click button. Did we win? Okay, basically that's the loop I'm doing. So I've kind of got some of these little functions here. Did win, kind of got that because I know if the moves is 0. Now if the moves are 0, though, we didn't win. So yeah, there's a little thing here that we've got to play. This is kind of my final end game aim to go to. So basically what we do is we're going to work with this process. And the idea behind this, I'm going to convert this visual thing into a data version of it. And I wanted to do this as image recognition. I don't want to just go into the HTML and look at the values. I actually want to say from a picture, as if I'm playing it by eye, going, yes, those are green, those are yellow. I think that'd be more fun. So one of the things you can do is you can access the pixel array by pixels equals im.load, and basically that gives me a 2D array which I can access. So I can say what is the color at, I don't know, PAX 30, 24, 30, 30. It'll give me the pixel color at that. Or it gives me a tuple of that value, and that tuple for this will be a 4-number tuple: red, green, blue, and alpha. I know all the alphas going to be 255, so I don't need to worry too much about them. So, first of all, we want to know the width and the height, because, as I said, it could be variable. Depending on how big this screen is, it could be variable in height. So I'm just going to quickly Google that. Image pill, image width. Whew. I don't want OpenCV, I want the pill version of this. And it is just dot size. Excellent. So I could do dot size here. That gives me a tuple, so I only care about 1. And I want to divide that by 14. And it gives me 20. Okay, so if I resize this, it means I always know the width of an individual square, and that's going to be really useful in a moment. The second thing is I want to set up my data to begin with, though. Now, I'm going to do this in a bit of a shorthand way. So the grid, this concept of the grid I want to play on, is going to be, I hate tuples, magic numbers appearing. Again, wouldn't hold up in work, but because this is nice and fun, 14 because I've got 14 squares on the grid. Okay, so it's going to be 0 to 13 on my references. I also, in all my coordinates, I'm going to use a cross of the first coordinate. So when I make this grid, even though it's a 2D array, so grid 1, 3 will be 1, 3, be there. Okay, just so people are aware. It may look a bit weird when you see the loops that I'm going to do, because we might loop vertically rather than horizontally first. But that's just how it is. So basically, 1 pixel border. So what we're going to do is then for I in range 14, for j in range 14, this basically makes me a 2D grid that's exactly the right size, so I can reference any element and convert that from a non to a colour in a moment. I's are across, J's are down. I'm going to put apostrophe in there because otherwise it is as across. So converting a coordinate, converting a grid coordinate to an actual pixel coordinate, is basically going to be across is equal to 11 because I start on 0, remember. So it's going to be 11, i.e. 1 pixel in plus half. It's not going to be 11. It's going to be this. It's going to be cell size. In fact, I'm going to do this here. Start point equals 1 plus cell size divided by 2. Start point plus I times cell size. And that's going to get me the center point of each cell. Because I think if I get the edge, if there's any kind of weird anti-aliasing going on, I might get a weird color or a weird color transition if there's some, for whatever reason, that's going to get me out. So I'm going to the center pixel, 1 pixel. Don't need to worry about colour averaging, don't need to worry about any of that. 1 pixel from the centre of every cell. And then what I'm going to do is do the same for the vertical. So down equals start point. Because it's a square, I don't need to worry about calculating the height and dividing that by 14 as well. It's actually start point. Plus j times cell size. Nice and easy. That's going to give me the point at every single point. Now, I don't need to think about that. I actually just need to go about colours. So very quickly, I need to work out all these colour values. So what I can just do is I can just say the colour. I program in American. I'm not embarrassed by that. I am English, but I program in American. Equals pix. Across, down. Cross has 1 C in it. And then print colour. For the moment, I'm going to do that, and then I'm going to do process grid. Process grid. Now, because that basically pulls it off the colour thing, it basically tells what the colours are. So these are the colours coming out. Now, one of the things I'm going to do is I'm actually going to set across to being black. And there's a reason I want to do that. And then here, I'm going to return. I haven't finished this here, by the way. I'm right there. I'm going to return the grid, and I'm going to return the image. So here I can do grid image equals that. Run that again, and then I can basically here just print off the image. Now, let me run get grid again to actually get the updated grid. Did get grid work there? I hope it did. It did. Process grid. Ooh. There we go. Variable reading refreshing. This little black dot means I can just check in the middle of every single one of those squares, and it hasn't. When I did a quick prototype of this, I was finding I was drifting, mainly because I didn't realise that every time I changed my browser window size, there was some weird hijinks going on. And so this just makes sure I'm always in line. Now, just to check that theory, I'm going to make this small again, and I'm going to run that all again. So I'm going to run from the start, get grid, process image, display the image. See, I'm still slap bang in the middle, maybe 1 pixel to the right, but I'm well enough away from all the borders not to have any weird. I see the weird artifacts coming in already. Just there's an artifact between the red and the green. where those divs are overlapping, or where the rendering is coming out a bit weird. Another yellow one there. I don't see. I can see it there better than I can see it there, but I want to stay away from those borders. Stay in the middle. These gives me all the colours. So what I'm going to do now is I'm just going to make sure I get all these colours, and I'm going to just put all those colours into an array for us. To save us a lot of typing, I'm just going to pretend that I did that live because I pre-prepped those. So those are all my colours. And I'm also going to bring in another set of hard-coded variables here of those colours. So I can not actually refer them as B1s and B2s, but actually as B6s and so on. Notice it's actually running this twice now because Chrome likes to run multiple browsers. So I'm going to go reset my browsers and start it all again. So go start the browser, load it. Notice if you get this wrong, by the way, if this is wrong, if I put HTTPS there, because they don't serve this as HTTPS, it actually doesn't load the browser, it doesn't show the browser at all. It just sort of dies on that run, which is a bit of a shame. Process grid, get grid. I'm going to go with that one for the moment. So get grid, and then view that grid, and then check those colours. Green, red, red, green, red, red looks about right. So what we're now going to do is we're now going to go into a bit of a nasty bit of code here, where we're actually going to look at the colours and we're going to say, do they match? So if the colour equals red colour, then the grid, and remember what I said is I's are across and J's are down. Well, I always want my coordinates to be across is J and I is down. It will mean if I try and print off the array just by doing print on the array, it will look a bit weird. It will actually look reflected. But I'll write a little print function in a second to help me debug that. So that equals red. That's going to equal B1. So I'm keeping those as my reference here. If color equals light color grid, and again I'm just going to copy and paste this down here. So basically this is now going to be I'm going to correct this in a second. 3, 4, 5, 6, and the colors will be light color, purple color, pink color, green colour. Again, hard coding these, not the best move. Very susceptible to them changing the colours in the game. They change the colours of the game and then all my system doesn't work. So this is yellow. So you have to be a little bit aware that this is only for fun and might not work tomorrow. What we call code rot. I've called this one light because I don't want to call it light blue, but just light. So yeah, this is susceptible to code rot. So any change in their code, any like changing these div names, anything like that, and the thing will have troubles. So as long as we're aware of that, the camera's reset for some reason. There we go. Then that's all we have to be aware of. I'm really sorry, my camera really has reset. There we go. I have loads of problem with my streaming setup today. Got a new camera. Hopefully the quality is better. Okay, so, like 30 minutes in already. This allows us to basically have a grid. If, however, I couldn't detect the colour of the grid, I actually want to throw an exception. So else, if there is, I'm going to print here, no match, and then I'm going to actually raise. Again, should we use a proper exception, i.e. a custom exception rather than just exception? There are reasons for that. But there are good, strong probing reasons why just using exception is bad. This is a bit of fun. So there's a reason I'm going for exception, which is, again, talking about this sort of final end game is I want it to fail here. The reason it's going to fail is because the game has finished or the game has been won. So the game has been won, it puts a nice little green screen over and the colours won't match. I won't be able to say, oh, this is definitely all green. So again, I'm going to run that there. I'm going to run get grid. I'm going to run this process grid again. I'm going to take that print out there because I don't really care about it. And then I'm just very quickly going to print the grid. So at this point, just check all those dots are still perfect. They're good. Print off the grid. And you see here I've got all these colours. Now to make my life just a little bit easier, I'm actually going to make a little grid print function here, which takes the grid. For I in range. I could probably do something a bit better than this. For J in range. 14. Now I want to loop around J because I want to go across before it goes down. So what we're going to do is print with a space in there, percentage, grid, and then J comes first, and then I, and then end equals no end. And then here I'm going to do print just to form the line ending. And I should be able to do here print grid, and that gives me that grid. So it should be B1, which is the green. B1 is green, so it'd be green, and then oh, hello. To me, this here looks like the L shape, so that is not right. I have made a boo-boo, and the boo-boo I made was I want to go across before I go down. Yeah, no, that's right. They're all the right way around. They're the right way around. Ooh. That doesn't look right around. It's very important when you do these things that you do test your element, unit test effectively. Make sure that you have strong confidence in some of these building blocks. I had a problem earlier where, because my samples weren't in the right place, I was getting the wrong results later on, and it was because the sampling was wrong at this point, not because my logic later was wrong. So basically, for I and most, this is going to move over every row. So I is definitely, no, I is down. Ooh, hello, that's wrong. No, that's right, I is going down, but I put I there, and that should say J, and that should say I. And here we should have, yep, that's the L shape, B5, B5, B5. Those ones there are the L shape of that L shape. If I look somewhere down here, little zigzag over here, you've got B1, 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 so that little zigzag down there. Working exactly right. That was a mistake on my part. See, can't get everything perfect. Okay, so now what we have now is a really nice representation, and we know we're always going to start here. So the tactic I'm going to use is basically say, look at this, look at what is in the cells adjacent to this B5 and B6, and work out which colours I can select. The thing about this game is, even though I've got green here, yellow and red, I could select light blue, and I can keep on clicking light blue. I'm just wasting lives in the game. So picking the right colour is really important, as opposed to the random game, which was just wasting moves. So here we are, and then yellow and so on. So what we're going to do now is basically make a decision based upon counting these cells. So the next thing we're going to do, and we're going to use recursion here. Now recursion, again, I kind of frown upon using recursion in practice, but it's quite handy. The reason I want to use recursion is because there may be situations where, even though I'm just going to start at the top left and look sideways and then look downwards, there may be situations where, for example, if I was red across here, I'd be wanting to look down here, but I also want to be looking backwards at this yellow, not just forwards. So you have to look at all the four sides of whatever square you're currently looking at. Now with recursion, it's very important to make sure you don't look at squares twice, and also I need to put bounds on to make sure I don't start recursing off the end and start trying to look at squares over here, which I have got out of bounds. So the way I'm going to do that is I'm going to start by making them a little, my calculator program. So def run or calc v1. I'm going to take a grid and it's going to return options. But first of all, it's going to keep track of what it has seen. So it always starts with 0, 0. Now I actually want to make sure that I serialize the coordinates. So I'm just going to make a very quick serialization function here to turn the coordinates into a string, which I can then say, have I seen this coordinate before? Str it x, y, and it's going to return percentage s in brackets, percentage x and y. That is what it's going to return. So basically, str it 0, 0. So basically, it's going to start. It's stopping you get stuck in a loop where you're basically bouncing from one cell to another cell. So my scene is which cells have I already seen. My primary color is going to be the colour at 0, 0, because this is always the colour I'm going to be at. And now, again, because I'm now working in real numbers between 0 and 13, I don't need to worry about calculating coordinates all the time. I can just work with these raw numbers of 0, 0. And then also, what I'm going to do now is I'm going to set my results array. I'm actually going to use a dictionary, and I'm going to use B1, B2, B3. I could use the variables here. B4, B5, and B6. Okay, and that's going to be the basis of my little calculator. I have left a comma off there. There we go. Now for my recursion, I'm actually going to use two functions to recurse over. So basically I'm going to use the one which, because the way I'm going to do it, so basically def view chord, it's going to take the grid, it's going to take the primary colour it's going to compare against, it's going to take whether the scene array, it's going to take the x and the y coordinate of where I am and the results. Okay? Nice and easy. And it's going to return, it doesn't need to return anything because it's already set. And basically I'm going to have another function which is actually going to process. So what this is basically going to do is going to add on the 4 points. So it's going to say process neighbor, grid, primary, scene, x, y, and results. And the process neighbor basically says it's going to look at the neighbor and actually work out what it's going on. Because this is 4 here, so basically it's going to do process neighbor, grid, primary, scene, x plus 1, y, and results. Like that. Nice and easy. It's going to do that 3 times. Now, the thing is that when I get to the end here, I don't want to do one more. So I actually want to do if x is less than 12, do that. Okay? And this is going to be repeated a couple of times, 3 times to be precise, because I've actually got if y is greater than 12, is less than 12. So if x is less than 12, I want it to go on. If x is greater than 0, then I want it to go backwards by 1. If y is greater than 0, I want it to go backwards by 1. Go down by 1. And those are my 4 decisions. Just go look at these elements and it's going to go into them. But I actually only want to process them if I haven't seen it before. So the first thing I'm going to do actually in the sub function is go target equals it xy, and if target not in scene. Always be careful when you're using recursion. Scene.append target. Now Python, the configuration variable of how many deep into a recursive block you can go, it used to be about 1,500, now it's about 3,000 by default, so I can go really deep. It's only ever going to get up to about 14. I think it's going up to about 28 because it's 14 across and 14 down. So to get to here, go 14 across, 14 down. But it could in theory take a very circular route to get there. If I didn't have these kind of controls, then it could go to the same point over and over again. So this just stops it. So if at this point it could be accessed by going across to it, all the way around to it, all the way around to the bottom to it, and so on. So there's actually an insane number of ways of getting to that, and it's an infinite ways if I could visit every single cell. I could just keep bouncing between the 2 cells forever. So this is really important that this target on the scene gets added to the scene. The moment it hasn't been seen, it's added to the scene. So if the grid y x, because y is across, x is down, and that's the way I've got my grid set up, if it equals the primary, then I want to basically put it back in here. So for this case, if this is the primary, I want to then continue on looking at it. So view chord grid primary scene x y results. I don't need to add anything on here because I added them on back here before I call this function. So at this point, the colour matches the primary. I've carried on. Now the colour doesn't match the primary. I don't want to carry on. It's not going to be consecutive, but I do want to know what the colour is. And this is going to be the base of my thing. So I'm now going to say else, this point doesn't match, results, grid y x, make sure I get those the right way around, plus equals 1. So it's going to add 1. So at this point it should get 2 pinks, a blue, a green, and another green. So 2 greens, 1 purple, sorry, 2 greens, 1 purple, 2 pinks. And no other number. I shouldn't get this green here, doesn't count. This yellow here doesn't count because they're diagonal. Okay. If it has been seen, I don't need to do anything. I can just pass and it'll just drop off the function and go back. Because I go across first, it's going to go across and then go down and across, down and across in the recursive way it's going to do it. It basically is how it's going to work. And back up to my function down here, I actually need to do view chord grid primary scene naught. Naught is my first coordinate I want to do, results. And then that, I believe, should be enough to get me a very quick attempt at going it. So we have run up here, we've run grid, so I've got a grid. I can now call my version 1 calc v1 grid. Immediately, of course, it blows up, which is kind of as you hope to. Primary equals grid not naught, because I didn't do a dictionary like that. So back up here, it's not a dictionary, so you can't pass it a tuple like that as an array index. There's a in neighbour. There you go. So as I said here, it's counted. Now it's come back with 1 5 and 1 6. A 6 is a yellow and a 5 is a red. So obviously it's looking at the wrong cells. Straight away I know that's exactly what's going on. And we can have a quick look at it. So having a quick look at this, it should have come back with I do apologise, that is actually right. It's a 5 and a 6 because I haven't run the grid again. So if I actually cause get grid again, process grid at that, and print grid, now it should give me the values back I actually want. There you go, how about that for test? It's come back with 2 B1s, B1s are green, that's what we want. 2 B2s, B2s are pink, which is what we want. And it should come back with purple to B3, 1 B3 and nothing else. How about that? The code works, 2 tests in a row, fantastic. Now this is interesting because the game actually could choose either a green or a blue at this point. So I'm going to pick the one which has the highest number of targets. And the way I'm going to do that is I'm going to use random choices. So I'm actually now going to start building out my actual main game loop to play. So options equals that. I'm going to do 4 key val in options items. I'm actually going to do found max equals naught. Max is equals an array. That's an array. So if the val is greater than the found max, then max is equals the key. I'm trying to avoid using the word max. Max is a keyword, obviously it's a function. May not be obvious. If the val is equal to the found max, I want the maxes to append the key. So at this point, after this last run, it will give me green and pink in the maxes. And then basically go if found max is greater than naught. Now, that will only happen at the end of the game. So I'm going to ignore that for the moment. I'm going to do maxes print. Let's just run that. So interesting. Interesting. Let me just print my options here. It should come back with B1, B2, and nothing else. But it's come back with B3, B4, B5, B6. So if the val is greater than the found max, max is equal to the key. That looks right. If the val is equal to the found max, then you know what? Found max equals val. There we go. Sorted. Nice and easy. So give it those print statements because I really care about them. What we're going to do now is we're going to do choice equals random dot choice maxes, and then we're going to go back to that original click. We're going to do, it's called button click, I think. I can't remember what my thing's called. Right, very early on, I've got click button, browser color. Click button, browser choice. So now it obviously picked the purple. This point there's 2 green, there's 3 green, 4 green. It's going to pick green, right? Guaranteed. This time, run it through, it's going to pick green. Now it's got 3 yellow, a pink, a couple of blue and red. It's going to pick yellow, I reckon. No, it picked pink. Obviously, I miscounted there, and it's going to run that every time. So that is now, ooh, got stuck in a bit of a loop there, where it's thinking pink. So there's obviously a miscalculation of logic. And again, let's debug that by printing. So one of the things that we may have messed up on is in this loop we are not calling getGrid and processGrid. So back at the top here, we actually now need to do getGrid, and we also need to reprocess the grid on every loop. Otherwise, we don't know what we're doing with. So that now flashes yellow, pink. We basically have the start of a program. We also know it hasn't won, so what we now can start to do is start to build a little bit more structure into this meta script around those functional items. So we get what we call business logic. In this case, it's not business; it's fun logic. So whilst it's playing, I'm going to use this master flag to keep it alive. So if get moves browser is greater than 0, because I know it's going to run out, greater than 0. Get grid browser. This also might error because remember the process grid, if it can't detect the colours correctly, so this is all going to potentially error at this point. I'm just going to put a massive try around the entire thing. Calculate the found max is 0, max is equals there. That comes along, that goes in by 1, that goes in by 2, that goes in by 2. That elf is for there. That is for there. Look at that. And then I can now tab these two in, and then I can do except, exception, print stopped due to an error, round over. I can check the screen and have a look what I actually have done. Play equals false. And I can also, at this point, there's an else there as well, print stopped out of moves, playing equals false. I'm also going to do a time.sleep 0.5 there, and the game is detected, it's out of moves, and we can restart the game. Let's click the middle of that one, and it can actually play the game properly. Now, as you can see here, it's making some rather good decisions. It's not the best AI. It's not looking at how big or how many, if I click blue here, how many purple. The other thing is it doesn't worry about enclaves. So enclaves are like that little green point there, or that red one there, where it doesn't give it a benefit to go for the red next, so they're not blocking. But the calculation said it's nearby, so it's 1 with 4 moves. I'm going to click that once to get reset, and we're going to start on 29 moves. Now, because I'm picking the value out, it's automatically only going to do 29 moves now. So it's not a fantastic bit of AI. It is a bit of fun. It is playing the game. It is making a decision, and it's making relatively good decisions to try and win the game. Whether it succeeds every time, oh, it's going to get close. Now that was interesting. It made some very dodgy decisions at the end there, picking yellow. I actually, I think I've seen this before in something similar. I think it's to do with this number here. I think that needs to be a 13, and that needs to be a 13. And I'm just going to put a thing in here saying if choices, if found max equals 0, print. Just print that. Got to remember to run that. I've got to remember to run my refresh my code up here for this 13. Okay, let's see if it will win another time. Still my first beer. How about that? Okay, we're getting right down the end. It's going to pick green. It's 1 of 3 rounds left. It seemed to make one more move there. It took a screenshot at least, but then decided to bomb out. I think it took a screenshot because the moves were greater than 0. It took a screenshot, but realised it couldn't process it, so it stopped due to an error. And the error was that if you actually look at the IM function here, it sampled all these colours. Actually, that's not the IM. That's not what I was expecting to see. But it basically says it errored on this. It would have errored and not returned an image, which is why you don't see it. But basically, this colour isn't the right colour green. That's why it fell over. And I can reset this, so we're down to 29 moves and run the game again. So again, a little bit more work. I can now maybe make it so it actually resets the game itself and keeps on playing. Maybe it keeps track of its highest score. Maybe it looks a bit more and says, well, what if I click blue? What would that do me? Rather than just saying which one gives me the most number of squares adjacent, but actually which one does give me the most number of squares than told. Because I've got a data model with that grid, I can clone that grid. See, it didn't get past 29 there. But as a concept, it works. You know, this is a bit of fun. It's a game. It's a bit of code playing a game. I don't like the flickering. I don't like that jumping up and down. That's just Selenium WebDriver. Maybe one of the other, not the Chrome driver. Maybe one of the one doesn't do it. But here we see we just won a game. And then play again. Oh. No, play again. I'm on 29 moves now. It doesn't beat me yet. I'm sure this will be something fun to play with in another evening and see if we can make it more optimal and start really analyse the grid a bit better and say, well, think 2 or 3 moves ahead. In my head, when I'm playing this, I play this before I go to bed. I'm only ever thinking maybe 2, maybe 3 moves ahead. Analyse those moves. See it run there right at the last square. I usually try and win. As I say, when I win with 5, 6 moves left to go, if not 10 moves left to go, especially on round 30. Or I lose for it. If you get a really bad grid, you're not going to win. That's it. I can actually design grids which are impossible to win. Even at 30 rounds, I bet I could design a grid which would be impossible to win. And that's it, really. That is the end of this episode. So if you enjoyed this, please hit like, please tell your friends, please hit subscribe. And if you have any comments at all, any questions, leave a comment down below or hit me up on Twitter. My Twitter is Jamons. And yeah, we're going to do more fun content coming up soon.